All right, good. So again, the whole point is for us to make sure that we understand where these things came from, and then we will be able to derive them and figure them out on our own. So we're not just going to go right to the formulas, we're going to try to figure it out. So we're going to start with, I'm going to show you the midpoint formula, and again, you're going to look at it and say, oh, that's ugly, that's terrible. But then we're going to just do finding the midpoint of 2 points on one axis. And we're going to do it, and you'll figure that out. And then we'll find it on 2 axes. And you'll figure out how to do it, and then you'll be able to derive the formula, and you won't have to memorize this long, crazy formula. You'll just know where it comes from. Okay, so understanding it. And then we're going to do the same thing with the distance formula. I'm going to show it to you. You're going to say, oh my gosh, that's horrible, that's terrible. Why would you make me memorize this? And then we're going to figure out how to use it without the distance formula so that you can use it for yourself and determine it where it comes from and understand it yourself. All right, so I'm going to start by showing you the midpoint formula. It looks really ugly and terrible. Okay, but when we get through it, it's not. So I'll give you a second to get that down in your notes. Again, we're going to have a notes page in a minute where I'll have this, but again, this is what it is. It just says that the coordinate of the x coordinate of the midpoint, xm, m stands for midpoint, is I just take my x1 and x plus x2 and put it over 2. Or that's also known as the average, adding them up and dividing by 2. And the same thing with my y. To find my midpoint of my y, I just add them up and divide by 2. So again, I know it's big and ugly and looks terrible, but as we go through it in a second, you will see that it's not. So I'll give you another couple seconds to get this down in your notes. x1 plus x2 over 2, comma y1 plus y2 over 2 is our midpoint formula. Or just again, think of it as the average of the 2 points. You add them up and divide by 2. Okay, it looks hard and difficult to memorize, so don't memorize it. Rather, we're going to understand where it comes from, then you don't have to memorize the formula. Okay, so we're going to start with what is the midpoint? It's the point in the middle of the line segment. You guys know that. We've done that before. And we know how to do this, right? If I just have 2 points and I said find the one in the middle, what you guys would do is you'd count how far the whole thing is. You'd say, well, what is that? That's 1, 2, 3, 4, 5, 6 units. That's 6 units. And then you'd figure out, well, what's half of that? What's half of 6? It would be 3. So now we just count by 3. 1, 2, 3. There's my midpoint. It's the one in the middle. I went 3 this way, or I go 3 the other way. It's 3 in the middle. That's all the midpoint is. It's one in the middle. Okay. And it's the same thing if we have numbers, but we add instead of counting for step 1. So let's just say I had between 0 and 6. What would I do? Well, I add the numbers. What is 0 plus 6? It's 6. Then I divide by 2. And that would be 3, and 3 is my midpoint. Okay, well, what happens if we have negative numbers? Doesn't matter, it's the same thing. Here are 2 different numbers, negative 10 and negative 4. What's the formula? You add up the numbers. Negative 10 plus negative 4 is negative 14. Then you divide by 2. Divided by 2 is negative 7. Negative 7 is the midpoint. Same formula, add them up, divide by 2. Okay? What if only one of them's negative? Same thing. Add them up and divide by 2. So what are our 2 numbers? Negative 4 and 2. Add them up, that'd be negative 2. Divide by 2. Gets us negative 1. Negative 1 is the middle, right in the midpoint. Okay. What about fractions? Oh, we hate fractions. What if it turns out to be a fraction? Doesn't matter. Add them up and divide by 2. So what if we take these 2? What if we have 2 and 7? 2 and 7 adds up to be 9. Divide it by 2. That would be 4.5, and 4.5 is my midpoint, right in the middle. Okay. Take the 2 numbers, add them up, and divide by 2, and that gets you the midpoint. Okay, what about the hardest one you can imagine? We got fractions and negatives. Doesn't matter. You just take the 2 numbers, add them up, and divide by 2. What is negative 3 plus 2? Negative 1. Divide it by 2, and we got negative 0.5 right there as the midpoint. Okay. So in coordinate geometry, that's our coordinate plane, you do the exact same thing we just did, except you just do it twice. Once for the x's, once for the y's. So what do I mean by that? So we're going to do it once for the x's and once for the y's. So here's a line segment, and I want to find the midpoint. So to find the midpoint, I'm going to call point 1 is x2, y2, and point 2 is x1, y1. Okay, so find the x values. So the x values are x1 and x1 and x2. And again, those are just like between there and there. Right? Those are the 2 points. So what's in the middle of those two? What's in the middle of those two is right there. Right? So I'm just looking at the x values, and the x values, I've got these two values, and that red line in the middle is the middle point. Okay, now let's do it for the y values. There are the two y values. So there's the bottom y value, there's the top y value. What's in the middle? Right there. Okay, so what's the intersection of those 2 points? Right there, that's my midpoint. Because that's in the middle, that's the two x values in the middle with the red, and it's the two blue value y's in the middle with the blue. And so that's the midpoint. Okay, now let's get rid of that. Okay, let's do the same thing, but let's do it with actual numbers. So now we have, let's find the midpoint of 0, 5, and 2, 1. Okay, so to find the midpoint, we're going to find the x and the y coordinates. First, the x's. The x's are 0 and 2. x1 is 0, x2 is 2. And the y's are 5 and 1. So find the midpoint of x. That's just add them up. In this case, 0 plus 2, divide by 2, and I get 1. Let's do the same thing for y. Add them up. 5 and 1, divide by 2, I get 3. And so I know that the midpoint is 1, 3 here. How'd I do it? I took the average of the x's, 0 plus 2, divided by 2, and the average of the y's, 5 plus 1, divided by 2. Okay? And the final thing I would do if I do all this work is I would check for sanity, see if this makes any sense. Right? Maybe I made a silly mistake. Maybe I put a negative down when I shouldn't have. Whatever. 1, 3. Where is 1, 3? Does it look like it's the middle? Yeah, that's on the line. It's the middle, right? If I had actually done 1, negative 3, I would have had the point down here, and I would have said, oh wait, that's obviously not right. That's not on the midpoint. And I could have gone back and figured out what I made a mistake. All right. Yes, that makes sense. So I know that I got the right answer here. All right. So any questions on midpoint? We started out by showing you this terrible formula, and I said don't worry about it, because all it really is this part is just the average of your x coordinates, right? The xm just means take this plus this and divide by 2, and this piece here is just your average of your y coordinates. Take y1 plus y2 and divide by 2. So hopefully if you understand those pieces, this isn't so ugly and hard to memorize. All right, any questions? Okay, great. Let's go to our notes page. So again, the midpoint is the point that divides the segment into two congruent segments. We knew that already. The midpoint formula on a number line, the coordinate that is the average of the coordinate points. So the midpoint would just be, in this case, a plus b divided by 2. And on the coordinate plane, it's the average of the x coordinates and the average of the y coordinates. And so there's your formula for your midpoint. So I'll give you a minute to get those down. Again, ugly, ugly formula, looks terrible, but as soon as you understand it's just the average, big deal. You've been taking averages since you were in the 5th grade or something, no big deal. All right, let's finish these notes in 1 more minute. All right, 10 more seconds. All right, so let's do a couple of example problems here. All right, so the first example problem is AB has endpoints of -4 and 9. What is the coordinate of its midpoint? So everybody try that one. And if you're done with that, you can try B and then move on to 2A and 2B if you're done with those. So let's spend a couple minutes trying these problems and then we'll go through them in a second. Everybody should be trying these 4 problems to make sure you understand the midpoint. All right, one more minute, and we're going to go through these 4 problems. You should have answers for all 4 in just a minute. All right, let's take a look through these. AB has endpoints of -4 and 9. What's the coordinate of the midpoint? Well, I take those 2 points and I add them up and divide by 2. So in this case, that would just be -4 plus 9 over 2. That'd be 5 over 2. So we can just call it 5 halves, or you can call it 2.5 or 2.5, but 5 halves is just fine. All right, EF has midpoints of, has endpoints of 7, 5, and 2, -4. What are the coordinates of the midpoint? Okay, so I just wrote down the formula there. I'm going to plug them in. X is 2 and 7, and Y is -4 and 5. So add those up and divide by 2, and I end up with 9 halves and 1 half. So you can leave it like that, or again, you could call it 4.5, 1/2, 4.5, and 0.5, whatever you want, but leave it as fractions is probably the easiest. JK has endpoints, -12 and 4 on a number line. What is the coordinate of its midpoints? Well, again, just take -12 and 4 and add them up. That's going to get you -8 over 2, which is -4. And what is the midpoints of RS if it's got points of 5, -10, and 3, 6? Again, I just want to add them up and divide by 2. So that's going to get me 8 over 2 and -4 over 2, which is just 4, -2. Any questions? Oops, sorry, any questions on these? Okay. These are pretty simple. Again, you just take the coordinates and add them up and divide by 2. So let's try the next kind of problem, which is that instead of giving you, like here, the 2 endpoints, and I'm going to ask you to find the middle, the next ones are I'm going to give you the midpoint and 1 endpoint and ask you to find the other endpoint. Okay, so I'm going to do the first one here. I'll do example 3, and then I want you guys to spend a minute or 2 to try example number 4. All right, so what's my formula? My formula is my midpoint xy is equal to the average of the x's plus the average of the y's. And so let's plug in the values we have. The midpoint is -2, 1. So I'm going to put those values in for the midpoint. My xm is -2. My ym is 1. I'm just going to take those and plug them in. And then my one endpoint is negative 5, 7. So I'm going to put that in for x1, y1. So it's negative 5 and 7. Plug that in. So now I have an equation. Okay, I'm going to break that up into two equations, one for x, one for y. Here's the one for x. Negative 2 equals negative 5 plus x2 over 2. Everybody see where I got this? This can be confusing. Just take my equation here, and now my x is this piece, and my y is this piece. Okay, so I take this. I'm dividing the whole thing by 2 over on the right, so I'm going to multiply the whole thing by 2. And when I do, I get 2 times negative 2 is negative 4, and then those 2's cancel, so I've got negative 5 plus x2. Just add 5 to both sides, and I've got x2 is the point 1. Now I got to do the same thing for y. I know what my x-coordinate is. I got to know what my y-coordinate is. So I'm going to do the same thing here. 1 equals 7 plus y2 over 2. Multiply the whole thing by 2, so the 2's cancel. And I'm left with 2 equals 7 plus y over y plus 7 plus y2. Subtract 7 from both sides, and I've got y equals negative 5. So now I know the endpoint is 1, negative 5. All right. Any questions on how we did this? Again, we just used the formula again, but in the past, we just always had x1 and x2, and to find the midpoint of x. Now we have xm and x1, and we got to find x2. So everybody try problem number 4. Try problem number 4. If you can do problem number 4, I'm confident you can do any problem involving the midpoint formula. So everybody try problem number 4. Make sure you can do that one. If you can do that, then I'm confident you can do anything we need to do on midpoint. Let's see if we can finish it up in 30 seconds. I'm not sure what we're going to do in a second. I'll let you know. It looks good, though. All right, so let's go through this one. So the formula, again, here's just my basic formula. And my midpoint. What's going to go here, Daniel? What's my midpoint going to be? Right, and the endpoint is going to go right here. What's the endpoint going to be, Daniel? Perfect, so I'm just going to plug that in like Daniel just said. So 4, negative 9, and negative 3, negative 5. Plug those in. Right, now I can just turn them into two equations. The x, so solve the x, multiply by 2 to get rid of the 2 on the bottom there, and add 3, and I've got x2 equals 11. Here's the y. Whoops, I was backwards. Okay, there's the y. Multiply by 2, and I get negative 18, add 5, and I have y2 is negative 13. My point is going to be 11, negative 13. All right. So any questions on this? If you can do this one, you can do any midpoint problem you're going to have. So if you feel good on this, I feel good about the whole thing here. Yes? All right. So now we're going to do the same thing we did for midpoint, we're going to do for distance formula. So I showed you the ugly, terrible, awful, no good, very bad formula to begin with. And by the end, you guys are like, oh yeah, that's easy. So we're going to do the same thing with distance formula. At first, it's going to look terrible and awful, and then we're going to go through how to do it, and you're going to be like, oh yeah, it's not so bad. Okay, so here's the distance formula. As I said, oh, that looks ugly and hard to memorize, and it is. So don't memorize it. Instead, we're going to understand where it comes from. But first, you need to write it down in your notes. I'll show it to you again in a minute, but here it is in your notes. Yeah. Ugly and hard to memorize, so let's not memorize it. Let's figure out where it comes from, and you can always derive it yourself or figure it out a different way. And after a while, you'll memorize it because once you understand where it comes from, it's obvious. And so you can memorize it that way. All right, so again, we're going to try to understand where it comes from, trying to figure out the distance between 2 points. Okay, so let's just pick TR here. I picked TR. TR has endpoints of 1, 4, and 5, 1. So I drew it there, and we're trying to figure out what's the length of TR. Okay, so what you can do here is remembering back to, I don't know where you guys learned at 7th grade, the Pythagorean theorem about right triangles. Notice that it's easy to turn any line into the hypotenuse of a right triangle. So there's the line, and that makes a right triangle. Draw a vertical line and draw a horizontal line, and now I have a right triangle. Right? I'm putting my mark there. Notice that mark there. Okay. So now if you want to find the hypotenuse of a right triangle given its legs, we use which theorem? The Pythagorean theorem, right? We use the Pythagorean theorem. The Pythagorean theorem just is a squared plus b squared equals c squared. So if I want to try to find how big is TR, what I can do is turn this into a triangle and then figure out, well, how big is T, or how big is A, and how big is B to get C. Okay, well, to get A, I can just count it. It's 1, 2, 3 units. To get B, I can just count it. It's 1, 2, 3, 4. And that's the thing, going straight up and down with a vertical line, you can just count the units because it's straight, or it's going straight across a horizontal line, you can count it. I can't count from T to R because it's a skew line, it's at a angle, so I can't count exactly how many it is. But I can count going straight up, and I can count going straight over, and I know it's 3, and I know it's 4, so now I can plug them into my Pythagorean theorem here. I'm just going to call that 3 and that 4. And now to get C, I just multiply it out, take the square root of both sides, and I end up with the square root of 25 is 5. So now I can figure out that TR in this case is 5 using the Pythagorean theorem. Okay. So you can always do that. If you don't want to use a distance formula, fine. Get out a piece of graph paper, draw it like we did here. Draw your vertical side, that's going to be one of the pieces in your Pythagorean theorem. Draw your other side, that's going to be the other piece in the Pythagorean theorem. Do it out. You don't need to use that distance formula. The distance formula is supposed to make your life easier. So if it's not making it easier, don't use it. But I think that once you start using it, you'll see that it is. Okay, let's do this exact same problem again. Okay, let's do this exact same problem again, except we're going to use it with the distance formula. So there's TR. And here's the actual distance formula. And so let's plug in our values. So x is 1 and 5, and y is 4 and 1. So I'm going to plug in my values, multiply it out. I get square root of 25, 5, same answer. Okay, you can start to see where it comes from. There's my 16 and my 9, same thing I had in the other problem. Okay, so now let's do it one more time. But instead of actual points, let's just put in x1, y1, x2, y2. Okay, so I'm not calling this, this look on here, it's 1, 4, but I'm not going to call it that. I'm just going to call it x1, y1. And for r, I'm not going to call it 5, 1, which is what it actually is. I'm just going to call it x2, y2. And I'm going to do the same thing we just did. Okay, except now, instead of being able to count, I'm just going to say that this red value here is y2 minus y1. And this x1 and the blue one is x2 minus x1. That's where they come from. Okay. So now just use my Pythagorean theorem. There's my Pythagorean theorem. There's my x values. There's my y values. Okay. So if I take the square root of both, I end up with the distance formula. That's exactly where it comes from. Here's our distance formula. Where did it come from? It came from the Pythagorean theorem, as we just did it right here. So you don't need the distance formula. You can always just do the Pythagorean theorem. But again, I think you'll see that after you do it a couple times, it's much easier to use the distance formula. So again, this is where it comes from. So hopefully you can understand it. All right, so within our notes, there is the distance formula. It's the distance between 2 points, and the formula is there. All right, so I'll do example problem. Actually, I'll give you a couple minutes. I'll give you a minute to get your notes down here, and then I'm going to do problem number 5, and then give you guys a chance to do problem number 6. Make sure you can do that. All right, 20 more seconds for notes. All right, so let's go through this first problem. So the first thing I'm going to do is I'm going to write down my distance formula. Then I'm just going to substitute in the values here. -7 and 4 for my x's, and 5 and -3 for my y's. So now we can just do it out. -7 minus 4 is -11. 5 minus -3 is 5 plus 3. That'd be +8. Multiply it out, 121 plus 64. I get the square root of 185, which if you put it into a calculator, it's about equal to 13.6. Okay, couple quick points. Number one is, what if I had flipped them around instead of saying, for example, 5 minus -3, what if I just said -3 minus 5? Well, I would have ended up with the same thing. Instead of having a +8 here, I would have had a -8, but when I square it, it becomes +64. So just like when we started doing the distance, the original distance of a segment, we said it's the absolute value of the difference of the coordinates. The absolute value always makes a positive. Well, here we don't need to do that because we are squaring it. And so -11 squared is 121, or +11 squared is 121. So that's why it's always going to be positive. So it doesn't matter which order you go in. Right? Second thing you need to be aware of is, again, how do I round? Right? You round by, again, looking at the digit after that. And if it's greater than 5 or higher, then you round up. If it's 4 or lower, you round down. Again, just reminding you how to do all that. All right, so everybody try problem number 6. Try problem number 6. You'll need a calculator for the very last step, but only the very last step. So you're saying a different order? Mm-hmm. Okay. Okay, right. So the order wouldn't. So if it was -7 minus 4, you're going to get -11. If it's 4 minus -7, that's 4 plus 7. That'd be +11. It would still be 121. So the order doesn't matter. You can go this x1 y1 and this, or this one x1 y1. Doesn't make any difference. Nope. Yep. Because that's what I was saying is you're going to square it. So it's always going to be positive. So it doesn't matter which way it is. Yep, so -3 minus 5 would be -8, and here you have 5 minus -3, which is +8, so same thing. All right, I see some people who are actually jumping to the very last problem because you're done with this one. That's great. So if you're done with this problem, you can go to the last one. We're going to go through this one and then the last one in just 15 seconds. All right, so once again, there's my distance formula. So I'm going to put in my values, -2 and 3, and 14 and -1. Okay, once again, it doesn't matter which order I go in, right? If instead of -2 and 3 here, I had gone the other way around and called it 3 minus -2, I'd end up with a +5 here. As it is this one, I'm going to end up with a -5. But -5 squared is 25, or +5 squared is 25. So the order doesn't make any difference. The order doesn't matter. All right, so then I just multiply it out. So it's going to be 25 plus 225. It's going to be 250. Take the square root, and it's going to be about equal to 15.8 after I round it. All right, let's take a look at problem number 7, which some of you have already started working on. Okay, on a zip line course, you are harnessed to a cable that travels through the treetops. You start at platform A and zip to the other platforms. Each grid represents 5 meters. All right, so how far do you travel from platform B to platform C? Okay, well, platform B, you can see the values here are -30, -20. Platform C, it's -15, +10. So I just put in my values here, and then I can multiply it out, and I'm going to end up with about 33.5 meters. All right, if you guys haven't tried it yet, everybody try the last one. Try from platform D to platform E. It looks like platform D is at 20, 20, and platform E is at 30, -15. So using those values, see if you can find the distance between D and E. All right, so how do I go from D to E? Well, there's my formula. Here's my values, 20, 20, and 30, -15. So multiply it out. It's going to be 100 plus 12, 25. And that's going to get me a distance of about 36.4 meters.